So bugün we'll talk about 5.5 indefinite integrals and the substitution method. Derdim ki bu yani integralların en vacip mevzularından biridir. Ona göre bu mevzunu yaxşı mənimsəmək cidden çok vacibdir. So try to do a lot of exercises, especially from this chapter, and I will do as much as I can to help you to understand this method and indefinite integrals. Indefinite integral, in general, we have two types of integrals. One indefinite, second definite. Indefinite integrals, I like this. We don't put borders like here and here, nothing. We don't put anything because indefinite. And we have here fx dx, and we get big fx plus c. Why c? Like we have discussed it before with few of you, but I will just go through it again. I will repeat it again because, for example, we know that derivative of x squared is 2x, and derivative of x squared plus 5 is also 2x. Derivative of x squared minus 6 is also 2x. Meaning x squared plus c derivative is 2x. It means that when we took antiderivative of 2x, meaning the indefinite integral of 2x, we cannot just write x squared because it can be x squared, it can be x squared plus 5, it can be x squared minus 6, but we don't know. We are not sure. There is nothing definite here. That's why we say it's indefinite, and that's why we should write plus c here. Okay. Definite integrals, I like this. We have lower bound, like we have borders, lower and upper. From a to b, it's written, read it like this: from a to b, upper bound, lower bound. Fx dx equals, we write it like this: big fx from a to b equals fb minus fa. So in this chapter we'll talk about indefinite integrals. Before indefinite integrals, like at 5.4, we talked about and we solved some questions related to definite integrals. If you remember and if you watched it, for sure. I know few of you did, because they asked some questions, but please watch it and ask your questions. Okay, I will just, yes. Now, yeah, we can also see it here. Substitution method. Substitution method is really related to chain rule. If you remember chain rule from derivatives, substitution method is the wise version of it. Meaning, when we how we do chain rule, let's say we want to find derivative of x squared plus 5x cubed. Like we want to find derivative of this function. How we do it? We say, let's say this is u, x squared plus 5x is u, and we find derivative of it. So it becomes like this: fx becomes u cubed. Yes, and we say let's apply chain rule is like this. dy over dx equals to, we include u, dy over du times d over dx, meaning derivative of y, this means that derivative of y in terms of u, this means derivative of u in terms of x, meaning here we'll get derivative of y, meaning in terms of u, so y equals something with u, derivative of u cubed, times derivative of u equals something with x, so this one, derivative of x squared plus 5x. It becomes 3u squared times 2x plus 5. We cannot keep u like this. We should, so u is x squared plus 5x. We should write 3 times x squared plus 5x squared times 2x plus 5. And that's it. I hope it's clear. So in substitution rule, we think like this. We are asked to find definite integral of, for sure, indefinite integral. This is indefinite. 3x squared plus 5x squared times 2x plus 5 dx. It's like this, and we should know that the answer is x squared plus 5x cubed plus c. But how we'll know that? Let's jump back to book. Let's look at the book. Okay. Oops. Yes. So if u is differentiable function of x and n is any number different from -1, the chain rule tells us, yes, we have talked about it. So we know this too. So this is rule. Let me just jump into substitution rule. For example, in this example 1 here, it says find the integral. What we will do? First, we will birinci, gəlin bunu Azərbaycanda izah edeyim. Nə edirsiniz? Bu şəkildə integrallar görəndə belə 2-3 dənə funksiyonlu baxırıq. Hansı funksiyonun derivativi digərinə bərabərdir? Məsələn, burada görürük ki, x kubu plus x-in derivativi nədir? 2x kvadratı, 3x kvadratı plus 1. Baxın, burada var. Bu demək ki, biz bunu u ilə əvəzləyə bilərik. Ən çətin şey mən deyərdim ki, substitution rule-da çox praktis lazımdır ona görə də bunu mükəmməlləşdirmək üçün ki, biləsiniz ki, nəyin əvəzinə u yazasınız. Yəni, ən çətin şey budur. Chain rule-da daha rahatdır u-nu tapmaq, yəni daxildəki funksiyonu götürüb u yazırıq da. Burada amma bilməliyik ki, nəyin derivativi digərinə bərabərdir. Yəni, əgər let's say we have fx times gx dx və əgər derivative of fx bərabərsə gx-ə, onda fx-ə u deyə bilərik. Baxın, məsələn, burada x plus x-ə u demişik. Then it becomes like this. du over dx times dx. du over dx meaning derivative of derivative of u, meaning derivative of this, 3x squared plus 1 dx. So bu necə olur? Deməli, götürürük burada x cube plus x-in yerinə u yazırıq. Buna da ki dedik ki bu du'ya bərabər olsun. Baxın. Yəni 3x kvadrat plus 1 dx-in yerinə də du yazırıq. O da olur u to the power of 5 du, u to the power of 6 over 6. Sonra da u-nun yerinə funksiyonun özünü gətirib qoyursunuz və cavabımız budur. Yəni bu şəkildə işləyəcəyik. İndi baxaq burada, burada da görürük ki, substitution rule theorem necədir? Bizim iki funksiyonumuz var, yəni f(gx) times g derivative x dx, g derivative x dx bizə verir du-nu, f(gx)'in də yerinə biz fu yazırıq. Çünki dedik ki, əgər derivativ yaza biliriksə, biz burada gx-in əvəzinə u yaza bilərik deməkdir bu. Bu şəkildə. Buradakı kitabdakı example'ların üstündən keçməyəcəm. Zaten solutionları var. Gəlin integral of sin squared, cosine squared, bunları təbii ki də əvvəldə 5.4-də belə suallar var idi. Məsələn, bunlar verilmişdi elə birbaşa. Yəni zaten 1 çıxısın kosinus 2x bölü 2 sinüs kvadrat x. Niyəsini soruşsunuz bu arada. Bu hazır formulaları əzbərləyə də bilərsiniz. Amma mən sizə tövsiyə eləyərdim ki, yadınızda saxlayasınız ki, kosinus 2x bərabərdir. Gəlin burada yazım. Kosinus 2x bərabərdir kosinus kvadratı x minus sinüs kvadratı x. Və bir də bilirik ki, sinüs kvadratı x plus cosine squared x equals 1. Meaning we can put, instead of cosine squared x here, so here we can find cosine squared x, it's 1 minus sine squared x. I will just put this instead of cosine squared x here. I will get 1 minus sine squared x minus sine squared x. Bu da bərabər olacaq 1 çıxılsın 2 sine squared x. By the way, yaxşın səsini eşitmişsiniz bilmirəm. Yəni əgər gəlirsə nəsə səs yağışın səsidir. 1 çıxılsın 2 sinüs kvadratı x. Heç bir şey. Buradan da sonra siz sinüs kvadratı x'i tapsız alacaqsınız ki, so kosinus 2x bərabərdir də buna. Sinüs 2 sinüs kvadratı x bərabərdir 1 çıxılsın kosinus 2x. Sinüs kvadratı x də bərabərdir 1 çıxılsın kosinus 2x böl 2. Yəni bunlar avtomatikdə yadınızda qalar bir müddət sonra. Amma yadınızdan çıxsa bu iki dənə formuladan tapa bilərsiniz. Kosinus kvadratı x də həmçinin bunun yerinə nəyi qoyacaqsınız? Sinüs kvadratı plus kosinus kvadratı x bərabərdir 1-dən sadəcə sinüs x tapmalısınız. Bu qədər. Belə. Bu şəkildə ilərləyir yəni. Gəlin example'lara keçək. Example'ların nə qədər bu arada suallar var. Theory və examples eləməyəcəm. Theory və examples'a qədər eləyəm. Çünki bu sessionu bu arada sayt uşaqları üçün çəkirəm. Sayt uşaqları üçün dediyim, çünki onlar 5.5-dadılar. Hələ digər uşaqlar, yəni biznesdən olanlar 4-cü chapter'dadılar. Ona görə yəni you can skip this video, but if you're interested, for sure you can look. So first we'll talk about evaluating indefinite integrals. Gəlin baxaq. Burada məsələn u-nu özləri veriblər. Burada da veriblər. Yəni bunların hamısında u-ları veriblər. Bunlar asan da olacaq, amma gəlin eləyək də sizə yolu göstərmiş olum. Məsələn 4-ü eləyirəm. Bizim var əlimizdə 4x kubu x üstü 4 plus 1 kvadratı dx. U-nu necə tapırıq biz burada? Bunu biraz böyüdək, bizə rahat olsun. Ay, sorry. Yes. Deməli, biz bilməliyik ki x üstü 4 plus 1-in derivativi nədir? 4x kubu. Baxın bunu aldıq. Bu o deməkdir ki, bu arada bunu gəlin derivativ şəklində yaxud du over dx şəklində yazacağım. Yəni dx falan yazacağım. Yəni prime-dan yazmayacağım. Prime-dan yazmayacağım. Çünki burada dx var və beynimiz qarışmasın. Deməli yazacağım ki d over dx x to the power of 4 plus 1 equals to 4x cubed. Yes, it's clear. Və mən deyirəm ki, gəlin, bu o deməkdir ki, yəni biz we can say 4 to the power x to the power of 4 plus 1-a u deyə bilərik. Yes. Və əgər hər tərəfin derivativini tapsam, meaning d over dx x to the power of 4 plus 1 equals d over dx. Hər tərəfin derivativini tapdım. Burada nə almış olacağım? Almış olacağım ki, bu bizə verəcək 4x kubu bərabərdir du over dx. I will find du here. Du equals, bu vurulsun dx. 4x kubu vurulsun dx. Now, gəlin sualımıza qaydaq. 4x kubu vurulsun dx'in yerinə yazacağım du. X üstü 4 plus 1'in də yerinə yazacağım u. So, olacaq integralım du. Yəni, gəlin du'nu elə yanında yazaq. Bura 1 yazaq. U squared du. Integral of this easy peasy. Oh, we know that we have formula minus 2 plus 1 over minus 2 plus 1 plus c. Never forget c, please. Equals, so this is minus 1 minus u to the power of minus 1 plus c. Instead of u, we cannot keep it like this. Instead of u, I will write x to the power of 4 plus 1. Yəni əvvəllə əvəzləmişdiksə, indi də əvvəlki versiyasına qayıtmalıyıq. Minus x to the power of 4 plus 1 to the power of minus 1 plus c. And this is our answer. And I hope it's clear. Now, gəlin bir dənə də trigonometrik bir şeylər eləyək. Ay, bu niyə belə olur? Yes. Biraz trigonometriya. Məsələn, 10-cuya baxaq. Onda nə deyirdi? Sualı görmədim. Integral of 1 minus cosine t over 2 squared sine t over 2 dt. Nice. Elə derivative of bunu biraz bu tarafa almaq istəyirəm ki, qələmi dəyişə bilim. Bu niyə belə olur? Yes. D over dx 1 minus cosine t bölü 2. Bizə nə verə bilər? Bizə verəcək, birin derivativi 0'dur. Cosine t bölü 2'nin derivativi çıxılsın cosine t bölü 2'nin derivativi. Minus'ı olduğu kimi saxlayıram. Cosine'in derivativi minus sine t bölü 2 times t bölü 2'nin derivativi. Yani minus plus verir. 1 over 2 sine t over 2. Baxın, bunu aldıq. So, we can write something like this. So, d over dx belə yazmayaq. Deməli, bu o deməkdir ki, buna biz u deyə bilirik. Let's take derivative of both sides, meaning d over dx 1 minus cosine t over 2 equals du over d. No, sorry, by the way, we have t here, so dx, no dx, but dt. My bad. Dt. So what we will get? This is, we know, 1 over 2 sine t over 2 equals du over dt. We need to find du. Du equals dt times 1 over 2 times sine t over 2. But we don't have 1 over 2 here, as you can see. So I will do something like this. So let's multiply each part with 2. So 2 du equals dt times sine t over 2. So instead of dt times sine t over 2, so instead of this, I will write 2 du. Why not? We can do that. And instead of this, I will write u. So it becomes what? I will write it here with the, yeah. So it becomes u squared 2 du. Can we write something like this? Yes, of course we can. And 2 is constant, so I can put it out of integral. U squared du becomes 2 u cubed over 3 plus c. Now we don't need parentheses. Yes. Instead of u, I will write, so 2 1 minus cosine t over 2 over 3 plus c. Cubed. Yes. By the way, it's 4 a.m. so if I do something wrong, like minus plus or like missing something, I'm sorry beforehand. I'm a bit sleepy. Like, I'm good, but I can do some mistakes. Sorry about that. Now let's look at another example. For example, 13 maybe? Yes, 13. I saw another good example, by the way. I will try to do it. So 13. So this part is easy because they say what is u, but in the exam probably they won't say, and we will also show some examples that they don't indicate what is u, so you should figure it out yourself. So okay, it's really believe me, it's not that much difficult. We can say u for this part. Don't ask me how do I know it. Like, yes, it's given in the in our statement. Okay, so if x to the power of 3 over 2 minus 1 is u, we'll take derivative of both sides, equals du over dx. It will give us what? It will give us, so the derivative of this part is 2 over 3 x to the power of 1 over 2 minus 1. No, minus 1. Equals d over dx. Meaning 3 over 2 square root of x. Okay, we got this. Equals d over dx. We always try to find d over dx. d over dx, du equals dx times 3 over 2 square root of x. We don't need 3 over 2 here, so I will multiply each part with 2 over 3. dx, like, let me write square root of x times dx. So instead of square root of x times dx, I will write du. Instead of this, I will write u. So it becomes not du, but sorry, 2 over 3. So it becomes something like this: sine squared u times 2 over 3 du. I will put it here, 2 over 3 sine squared u du. We have talked about how we find sine squared u du, so it's task. It's like it's given, so I won't repeat it, and please do it by yourself. Now let me do some interesting examples. From 17 to 66, we have to find what is u by ourselves. Yeah, it's a tricky part. I won't do all of them. I mean, if I had time, believe me, I would do it, but I don't have time, and I don't think it's fair for you to solve everything. Let me, for example, choose 24. Yes, why not? So 24, it says find the integral of, by the way, did I put plus c here? Yes, here. Yeah, cool. I thought I forgot it. Yes, it looks creepy, yeah, but it's not. It's one of the easiest integrals, because we know that derivative of tangent is secant squared x. So we can write u equals tangent x without hesitation. Take derivative of both sides. d over dx equals d over dx tangent x. So this part is secant squared x, and we need to find du. du equals secant squared x dx. Instead of secant squared x dx, I will write du. Instead of tangent, I will write u. It becomes u squared du. And this is u cubed over 3 plus c equals u is tangent x, tangent cubed x over 3 plus c. This is the answer. Let's go and let's take another example. For example, I don't know, maybe 28. R to the power of 4, 7 minus r to the power of 5 over 10 cubed dr. What can be our u? So for sure integral of r to the power of 5 will be r to the power of 4, so of course this is u. It's obvious. U equals 7 minus r to the power of 5 over 10. It becomes, so we took derivative of both sides, d over dr 7 minus r to the power of 5 over 10 equals derivative of 7 is 0 minus r to the 4, 5r to the 4 over 10, 2 minus r to the 4 over 2. We need to find r to the 4 times dr. R to the 4 times dr equals minus 2 du. So instead of r to the 4 times dr, I will write minus 2 du equals, instead of this we'll write u. U cubed times minus 2 du. I will put minus 2 here because why not? Minus 2 integral of u to the power of 3 du becomes minus 2 u to the power of 4 over 4 plus c. Instead of u I will write this, minus 7 minus r to the power of 5 over 10 over 2 plus c. You can make it simple, but this is the answer. Let me do another example maybe. Do I have something like much complex? I don't know. I don't think this all. They're not difficult that much. They're not that much difficult. Let's look at here. Maybe maybe something with ln. Yes. Maybe I don't know. 60 is easy. But let me do it. Yeah, why not 60? 60. So it says, where's 60? It says integral of 1 over e to the power of 2 theta minus 1 d theta. Yeah, what can we do? What is difficult here? Difficulty is that we have both square root and e to the power of something, so we should make it simple. We can say u equals e to the power of theta. Yes, I mean, I don't know, I'm trying. We can check, by the way, you can you will face, like, you will see some functions where you can put, instead of u, not instead of u, but you can put you can say for few functions that they can be u, but you will try and see that one of them does not work but one of them does work, or maybe both of them works, or maybe like both works but one of them is longer way than other. So it really depends. So I'm really trying, like, I'm just guessing. So I will take derivative of both sides, d over d theta e to the power of theta. This will give me e to the theta. My goal is to find du. Yes. Okay. It is something. So, what I'm gonna do? What I'm gonna do is, I need something like this, yes? So, I can multiply denominator and denominator by e to the power of theta. Why not? Am I allowed to do that? Yes, you are. Believe me, you are. -1. Oops, sorry. D theta. Now, what I have? Now, oh, I have e to the power of theta times d theta. So instead of this, I will just put du. Instead of e to the power of theta, I will put u. I will put u squared because it's e to the power of 2 theta. So it becomes 1, and here du, u times square root of u squared minus 1. This is famous formula for, like, this is integral of Redi formula for seconds, inverse seconds function, and I don't know if you do really remember or not, but this is like Redi formula. Instead of u, I will put e to the power of theta seconds inverse e to the power of theta plus c, and yes, this is the answer. Probably you will have a lot of questions here, but yeah, I cannot do I cannot solve all the questions. But if you ask specific questions, I'm glad to, I will be more than glad to solve them and help you to understand substitution rule. Again, it's like chain rule, but for integrals. Vice version of chain rule. Yeah, we do everything like inverse. Inverse operation, yeah. This is all from my side, my part, from 5.5. 5.6 is about, again, substitution rule and area between curves, but this time we will discuss substitution formula for definite integrals. I will keep it for another video, or maybe we'll do, I don't know, offline session. I'm not sure. We'll see. Love you. Bye.